Hey guys, so let's discuss new Apple interview loop, which is round. Sorry, yeah. So which is called behavioral round. Okay, round six, and here, see, this round evaluates leadership, ownership, judgment, collaboration, learning ability, and technical impact. Okay, at the architect level, Apple is not only interested in what you did, the interviewer wants to understand how you make difficult technical decisions, okay, and then how you influence teams, how you handle ambiguity, how you respond to failure, how you balance engineering and business priorities, how you learn from mistake, and how your technical decision creates measurable impact. Okay, so for behavioral question, a strong structure is something like this: a star method. Okay, so situation, task, action, result, and then what was the learning with it. For architecture level answer, add you can add business impact, technical trade-off, and then long-term prevention. Okay, so with this star you can add these three things also. Now, question one is, let's say, tell me about the time you improved application performance. Okay, so software engineer will say that in one project, we noticed that API response time has increased significantly. I first collected latency metrics and profiled the application to identify the bottlenecks. I found that some database queries were inefficient and that the application was making unnecessary calls. I optimized the queries, added the appropriate indexes, and reduced unnecessary calls. Okay. After deployment, I measured the improvement and verified that latency had returned to the expected range. So now, what senior software engineer will say? A senior software engineer should solve performance issue systematically. First, identify the problem and then collect relevant metrics. Then use profiling. Profiling means analyzing the information. Okay. Then use profiling to find the root cause. Apply the necessary optimization and perform load testing. Finally, validate the improvement in production to ensure system performance reliably at scale. Okay, so now he will discuss trade-offs here, like whether he will go with CPU or he will go with the memory. Okay, CPU optimization or memory optimization. Then database versus cache, whether he will use the database or he will be calling the cache for particular information. Okay, then latency versus cost, and synchronization versus asynchronous processing, synchronous versus asynchronous processing. Okay, so architect will, I would explain not only how I reduced the latency, but why the performance problem uh, existed at an architectural level. Okay, and then he will discuss about the baseline performance, then P9599 latency. Okay, bottleneck identification, capacity impact, infrastructure cost, user experience, business impact, and then preventive measures. So now follow-up question will be here. How did it impact the business? So the performance improvement reduced checkout latency, which improved the user experience and reduced request timeouts. It also reduced databases and infrastructure load, allowing us to handle higher traffic without proportionally increasing infrastructure cost. Okay, so now quantify wherever possible. So for example, 40% lower latency, let's say, and 30% fewer timeouts. Okay, so you have to use this calculation, this mathematics in your answer, like um, means what changes, what effect happen. Okay, with your changes. So like 20% lower infrastructure cost, higher throughput, fewer production incident. Okay, the key is don't stop at API become faster. Explain why it is matter to business. Okay, so you have to explain that why part. Okay, question number two is, tell me about difficult production bug. So software engineer will say that use a structured debugging approach. Okay, so like he will say that when a production issue occur, we first assess its impact to understand how many users or services are affected and how critical the issue is. Okay, we then realize logs and metrics to identify abnormal behavior and gather evidence. Next, we reproduce this issue to isolate the affected component to narrow down the problem. Once the root cause is identified, we implement the test and appropriate fix. So finally, we validate the fix in production by monitoring key metrics and confirming that the issue is fully resolved without introducing new problem. Okay, so what you will explain there? You will explain what happened, how many users were affected. Okay, then how did you detect it, and then what was the root cause for the problem? How did you fix it, and then how did you validate the fix? Senior software engineer will say, he will discuss apart from these things, he will also discuss that incident management. Okay, how you have managed the incident, then communication mitigation versus permanent fix, rollback monitoring, and then root cause analysis. So now, for example, our first priority was to reduce customer impact. We rolled back the problematic release while investigating the root cause. Once the system stabilized, we reproduced the issue in a controlled environment and then identified the underlying race condition. So yeah, they try to reproduce it and then they fix it. So now architect will say, show that you think beyond the immediate bug. Okay, so what you will say that when an incident occurs, the first priority is to mitigate its impact and restore the system to the stable state as quickly as possible so that customer will not suffer. Once the immediate effect is under control, we perform a root cause analysis to understand why it happened. Okay, we then implemented a permanent fix to address the underlying problem. After that, we look for architectural improvement that can make the system more reliable, scalable, and resilient. Finally, we introduce preventive measures such as better monitoring, alerts, testing, and then safeguards to reduce the chance of the same incident happen again. Okay, so same thing should not happen again, so that they will do the permanent fix by finding the root cause. Okay, then architect follow up. So they will say that how did you measure it never happened again? They have fixed it, right? So how you will fix? So don't say that we just fixed the code. You have to say, you have to discuss about your regression test, your monitoring, your what you saw on the alerts. Okay, then canary deployment, then code review improvement, architectural changes, failure injection, run book, and then automated validation. For example, you can say that we fixed the immediate issue, but more importantly, we identified why our existing test couldn't detect it. We added the concurrency test, introduced a production matrix of for the failure condition. Okay, and then added an alert and changed the deployment process to use canary rollout. So all these things you have to mention there. The strongest answer will be like incident came, what was the learning, and then systematic improvement, what you did. So question third will be about tell me about a design decision you regret. Okay, so software engineer will say that early in my project I chose synchronous approach because the initial workload was small. As traffic increases, the synchronous dependency became a bottleneck. Okay, so he has to introduce there a queue. So he will explain there about why you made the decision, what information you had at that time, and then what changed and what you learned from it. So avoid blaming other people's. Okay, while answering. Senior software engineer will say that we start with the initial requirement and design a simple architecture that is sufficient for the expected scale. Okay, as the system grows and the load increases, we monitor its performance and identify when the existing architecture starts becoming a bottleneck. At that point, we analyze the limitation and redesign the architecture to handle the increased and scale, improve performance, and maintain reliability. Okay, what architect will say? So he will be saying, given the information available at that time, the decision was reasonable, but I underestimate how quickly the workload would evolve. Okay, so workload was initially it was low, but then it became higher, and then the mistake was not the initial design itself, it was failing established as an explicit trigger for revisiting the architecture. Now what will be the architect follow-up here? So how would you redesign it today? So he has to explain here what changed, what would you keep, and then what would you remove, what would you introduce, and why. So for example, like old design was using just service was calling databases, but now you have to introduce their cache in between service and database. Okay, then queue also, so that database hit will be lower and the latency would be higher, but don't introduce complexity simply because it sounds architect level. Okay, Now, question number 4 is describe a situation where you had to balance user, okay, where you had to balance user experience with engineering complexity. So, software engineer will say that user, see, let's say user wanted to near real-time updates, okay, but implementing a fully real-time architecture would have significantly increased complexity. We evaluated the actual freshness requirement and determined that polling every few seconds was sufficient, right? So we'll compare here alternatives. For example, option A is real-time WebSocket plus, so what real-time WebSocket will give you, the latency will be low but the complexity will be higher there, okay. Option B is polling, so here higher latency but lower complexity, right? So choose based on the requirement rather than the technology preferences. Senior software engineer will say that evaluate the user experience, latency, reliability, engineering effort, operational complexity, cost, and scalability, and use measurable requirements. Okay, according to these requirements, just make your decision. For example, the product requirement was update should appear within 5 seconds. Okay, a WebSocket architecture could achieve sub-second updates, but the business requirement did not justify that complexity. Okay, so what architect will say? Architect will say that frame the decision as a product plus technology optimization problem. Okay, so here you have to optimize product also plus the technology you are using in it, that also you need to optimize. The goal is to improve the user experience, but every improvement can also introduce additional complexity and cost, right? So at the decision point, we evaluate whether the expected business value for the better UX justify the added development effort, operational complexity, and maintain cost. Okay, we choose the solution that provides the best balance between user experience, business value, and overall cost. Architect follow-up. What will be the architect follow-up here? How did you make the final decision? So he will say that see, I first clarify the actual user requirement rather than assuming that the most technically sophisticated solution was necessary. Okay, we evaluate the alternatives against latency, reliability, development effort, operational complexity, and cost. We selected the simplest solution that met the user facing requirement and defined metrics that would tell us when a more sophisticated architecture would become necessary. Now question number 5, this is the last one. Okay, so tell me about a project where security influenced the architecture. Everywhere, right? So software engineer, what he will be saying, we were handling sensitive user information, so instead of storing credential directly application database, we introduced a tokenization approach and restricted access to the underlying sensitive data. Now what senior software engineer will say, he will explain the thread model, then least privilege, then encryption, key management, network security, and auditability. Okay, so architect, what he will be saying, he will demonstrate that security was considered before implementation, not added afterwards. Okay, so because the system handled sensitive customer data, we treated security as a first class architecture constraint. We identified the trust boundaries and then minimized the amount of sensitive data services could access. Okay, encrypted data in transit and at rest, centralized key management, implemented least privilege access. The increased implementation and operational complexity, but significantly reduced the blast radius of a compromised service. Okay, so architect follow-up. What will be the architect follow-up here? What trade-off did you make? So means trade-off means you have to choose one thing and you have to not choose another one, right? So for example, a strong answer should acknowledge that security has engineering cost. Okay, so for example, if security decision, let's say if you go with the encryption, so what will be the trade-off here? CPU and latency overhead. Then strong authentication, so additional user friction. If you go with the least privilege, then more complex authorization would be there. Then tokenization, so additional infrastructure, audit logging, storage, and processing cost. Key rotation, so operational complexity. Then network isolation, so potential latency or complexity. So then explain why the trade-offs were justified. So that's it. Thank you.